Hello, Algebra 1. Today we're going to be starting section 8.5, which is on factoring trinomials when a equals to 1. This is a very important lesson, so make sure you pay close attention. If you have your algebra tiles, take those out too, because we will be using these in the beginning part of our lesson. So let's first talk about what do we mean when we're factoring trinomials, and what does it mean when a equals 1? Well, first off, let's look at that word trinomial. This is a word that hopefully we've seen before. That prefix tri hopefully reminds you of 3, right? Tricycle has 3 wheels. A triangle has 3 sides. What is a trinomial? A trinomial is just a polygon with 3 terms. So if you look at all the questions that we have on our worksheet, right? Every single one of those polynomials have 3 terms, right? And that's what we call a trinomial, okay? The next thing we're going to talk about is what do we mean when we say a equals to 1? If you look at every single quadratic term, right, that's a term whose variable has an exponent of 2, x squared, c squared. If you look at the number in front of those terms, it's always a 1, right? So when we say a equals 1, what we mean is that the leading term has a coefficient of 1. So anytime you see 1x squared, that's really just x squared, right? And that's how we usually write it, okay? Lastly, what does it mean when we factor? Right? What are we doing when we're factoring trinomials? What we're doing is we're writing it as a product. Something times something is going to equal this trinomial, right? Something times something will equal x squared plus 5x plus 6. So when we're factoring a trinomial, all we're doing is rewriting it as a product of 2 or more expressions, okay? So we're going to be looking at trinomials and how to factor them using algebra tiles. So let's go right into number 1 here. We have x squared plus 6x plus 8. So what I want you to do is get your algebra tiles out. Get out an x squared tile. Get out 6 of these. And then lastly, get 8 of these individual ones. Using these algebra tiles will give us a much clearer picture of what we're really doing when we're factoring. So once you get 1 x squared tiles, 6 x's, and 8 ones, our goal will be to rearrange these tiles until we form a rectangle, okay? So typically when you create this rectangle, you want to start with your x squared term, okay? Here I'm going to put my x's next, and then you'll do the ones at the very end. So I'm going to try to see if I can form a rectangle that has 3 going this way, horizontally, and 3 going vertically. And then I'm going to try to fit my ones in here. And let's see what happens. Now if you notice, I'm just 1 tile short. And unfortunately, we can only work with x squared plus 6x plus 8. And so because this does not form a rectangle, this does not work. Now look what's going to happen when I rearrange it by putting this x squared over here. I'm going to also move these ones over here. And if you notice, we form a rectangle. And this is what we're trying to do, okay? Create a rectangle using the tiles that we have. At this point, what I'm going to do is I'm going to draw this picture on the side. So I'm going to draw my x squared tile here. I'm going to draw 4 of my x's going this way. And then I'm going to draw 2 going horizontally. And then lastly, I'm going to draw my ones tiles. And then from here, we're going to find the dimensions of this rectangle. So if you notice, x squared plus 6x plus 8 actually represents the area of the rectangle. What we're going to do is find the length and the width of this rectangle. Now, if you remember, this rectangle, this square, this x squared tile has lengths x and x, right? Each of these short ends of the rectangle just has length 1. Similarly, 1 here and 1 here. And so when you look at the length of this rectangle, you'll get x plus 4. And when you look at the width of this rectangle, you'll get x plus 2. And so what we have is a rectangle of dimensions x plus 2 by x plus 4. And so what we're going to do now is when we write down our final answer, we're just writing the dimensions of this product, right? The length times the width will give me the area of this rectangle. And because x squared plus 6x plus 8 represents the area of this rectangle, I know that I can rewrite this as x plus 2 times x plus 4. And this would be my final answer. So if you notice, when we factor our trinomial, we're just writing it in terms of the length and the width, and we're just multiplying them together. So that's our first example. If you remember in the past, when your screen says your turn, I want you to pause the video and I want you to try the problem on your own. So see if you can do number 2 using your algebra tiles. So here you should have started off with an x squared tile. You should have gotten 5 of these. And you should have used 6 ones. And what we're going to do is we're going to rearrange this into a rectangle. So maybe I'm going to put 3 this way. I'm going to put 2 this way. And then I'm going to fit these ones in. And if you fit the ones in like this, you notice you can form a rectangle. Voila. If you put 3 rectangles going this way and 2 going this way, that will be fine, right? You'll get the same answer in the end. Now that we formed our rectangle, hopefully you drew this out, right? This is my x squared tile, which again, if you notice, is always on the top left corner. Then I'm going to put my rectangles here. I'm going to put 2 more going horizontally. And then I'm going to put the ones tiles in the bottom right hand corner. Now from here, I know that this square, this x squared tile has dimensions x by x. Each of these short ends of the rectangle has length 1. Same thing here. And so when I look at the length of this rectangle, I get x plus 3. And when I look at the width of this rectangle, I get x plus 2. And so once again, x squared plus 5x plus 6 represents the area of this rectangle. So to rewrite the area of the rectangle, I'm going to write it as the length times the width. Here my length is x plus 3, and here my width is x plus 2. And this would be my final answer. I just factor this trinomial. Now some of you guys might have written x plus 2 times x plus 3. And if you did that, that's also correct, because when you're multiplying, order doesn't matter, right? It's commutative. And so this is what we're doing when we're factoring a trinomial. All we're doing is we're writing this trinomial as a product of 2 things. In this case, it's a product of 2 binomials, where each binomial represents one of the sides of the rectangle. So this is how you factor using algebra tiles. Alright guys, we're going to continue our lesson on factoring trinomials when a equals 1, except this time we're not going to be using algebra tiles. However, what we're going to do is we're going to follow a structure very similar to what we did when we use algebra tiles. And the way we're going to do that is by creating a Punnett Square. This should look familiar to you guys. This is what we use when we learned how to multiply binomials together. Now, if you look at examples 1 and 2, right, when you look at the top left-hand corner, that's where we put our x squared term, right? So if you look at our problem that we're doing, I have a single x squared. So I'm just going to put x squared in the top left-hand corner. If you look at the bottom right-hand corner for both of the examples that we did previously, you notice that's where we put our ones tiles, right? That's our constant, essentially. Going back to our problem here, my constant is plus 12. So I know I need 12 of those little tiles on the bottom right-hand corner. Now from here, we want to figure out how many rectangles do I need to put here and how many rectangles do I need to put here. And so the way we're going to figure that out is by creating this x. By the way, this is what we call an x box problem, right? Before we just practice the x's, I'm going to put a times here and a plus here, right? And so the way we're going to figure out what goes on top and the bottom is you're going to go back to the original problem. In this case, the constant 12 is going to be what our product is going to equal. And then to figure out what number goes on the bottom, you're going to look at the coefficient of my x term. And that's going to be what my sum will be at the end. And so now from here, we need to think of two numbers that multiply to 12 and add up to 7. I'm going to first try 1 and 12 because that multiplies to 12. But if you notice, when I add them up, it gives me 13 instead of 7. Two different numbers that multiply to 12 would be 2 and 6. But if you add those up, you get 8 instead of 7. So that doesn't work. If you try 3 and 4, that does multiply to 12, and it does add up to 7. So those are going to be the two numbers we put here. Now those numbers that we just came up with will actually be the number of rectangles we need in each of the corners. So in the bottom left-hand corner, I'm going to put 3x here. In the top right-hand corner, I'm going to put 4x there. It doesn't matter where you put the 4x and 3x, by the way, because at the end, you'll still get the same answer. Once you fill in this Punnett square, what you want to do next is you want to find the dimensions of this Punnett square. And the way we're going to do that is first put x here and x here, because I know x times x is x squared. Essentially, we're just working backwards, right, to find the dimensions of this Punnett square. Now I'm going to ask myself, x times what gives me 4x? That would just be plus 4. X times what gives me 3x? That would just be plus 3. At the end, my final answer will be x plus 3, x plus 4. And if you notice, my final answer consists of the dimensions of this Punnett square. And this is what I get when I factor this trinomial. So hopefully you see the similarities between the problem we just did and when we use algebra tiles, right? They have that very similar structure. And understand that when we factor, what we're going to be doing is this Xbox setup. Let's scroll down to number 4, and let's actually try this one together as well. So just like before, I'm going to create a Punnett square. And I know in the top left-hand corner, that's going to be my c squared. Let me just kind of color code this so you can see where these terms are coming from. I know on the bottom right-hand corner is going to be negative 20. And I got negative 20 because of the fact that that's my negative 20. From here, I want to figure out what goes here and what goes here. And the way we're going to do that is by creating another x. I know the top number is going to be my product and my bottom number is going to be my sum. And once again, to figure out that top number, it's just going to be my constant. To figure out the bottom number, what I'm going to do is I'm going to look at the number in front of my c term here. Except in this case, there's no number, so you just put a 1 there. So technically, there's a negative 1 in the front. So I know that my sum needs to be negative 1. And this is our Xbox problem. From here, you want to think of two numbers that multiply to negative 20 and add up to negative 1. So I know that one number has to be negative and one number has to be positive. It looks like 4 and 5 would be the two numbers that might work. So here I'm going to first try negative 4 and positive 5. When I multiply them together, I do get negative 20. But when I add them up, if you notice, I get positive 1. But I want to get negative 1. So I know that my negative shouldn't go there. What I'm going to do instead is put the negative in front of the 5. Now, if you double check that, you notice that the sum is negative 1. From here, I know that I could put 4x here on the bottom left, and I could put negative 5x on the top right. And then from here, what we want to do now is we want to fill out this Punnett square. I'm always going to start with the first box because c times c gives me c squared. By the way, be careful with what I did here. If you noticed, I called this 4x and 5x, but really it should have been 4c and negative 5c, right? So make sure the variables all match. Now going back to this, I know that I'm going to ask myself, all right, so c times c is c squared. C times what gives me negative 5c, right? It'll just be minus 5. C times what gives me 4c, just positive 4. And again, we can always check to see if I get this last number, right? So 4 times negative 5 does give me negative 20, and I like that. It's a nice little way to just check. Most likely, if you got up to that point, right, you probably got the right answer. From here, though, your final answer will be c plus 4 times by c plus c minus 5. And again, how did we get this? We took the width and we took the length of our Punnett square, and those are the two factors. This is our final answer for number 4. hopefully you get an idea of how we're creating this Xbox problem to factor these trinomials. At this point, I want you to look at number 5. I want you to pause the video because it is your turn. So looking at number 5 here, we're going to first create a Punnett square. Put an m squared in the top left-hand corner and put a negative 20 on the bottom right-hand corner. From here, we want to create an x where the top is going to be my product and my bottom is going to be my sum. And if you guys remember again, this negative 20 is going to be my product. To figure out my sum, I'm going to look at the number in front of the m. In this case, it's just negative 8. And now I want to think of two numbers that multiply to negative 20 and add up to negative 8. If you got negative 10 and positive 2, you're correct. At this point, I'm going to put negative 10m here. And I'm going to put 2m here. And then from there, we're going to make a times table. I know that m times m gives me m squared. Now I'm going to ask myself, m times what gives me 2m? That would just be positive 2. M times what gives me negative 10m? That would just be minus 10. And again, I'm going to just check, right? Negative 10 times positive 2 is negative 20. That is good. From here, I'm going to write down my final answer, which will be m minus 10, m plus 2. If you got this right, very nicely done. If you made any mistakes on the way, it's okay. Make sure you learn from your mistakes because these problems are not simple. I'm going to give you guys one last problem to practice on your own. So try number 6 and let's see how you do. Creating another Punnett square. The top left will be x squared. The bottom right will be positive 30. To figure out what two numbers go here, I'm going to create an x, right? The top is my product. My bottom is going to be the sum. Going back here, that 30 is going to be what my product is. And then to figure out my sum, I'm going to look at the number for my x term. That's going to be my sum, which is negative 11. Now from here, I want to think what two numbers multiply to 30 and add up to negative 11. In this case, they're both going to be negative 5 and negative 6. And once you figure out those two numbers, we're going to put them in the bottom left and the top right boxes. Those are my rectangles, right? And now from here, we're going to fill out this Punnett square, right? We're going to work backwards now. We know x times x gives me x squared. X times what gives me negative 6x? It should be minus 6. X times what gives me negative 5x? It should be negative 5. And then we're just going to check this last box. Negative 5 times negative 6 does give me positive 30. I like that. Now from here, when we write down our final answer, we're going to write x minus 5. X minus 6, and that is our final result. So this is factoring trinomials when a equals to 1. All we're doing is creating this x box, right? And eventually we're trying to find the dimensions of our Punnett square. So take a very close look at what we did in today's lesson, because this is something that you're going to see a lot in the future. This is a very important concept. This is a skill that you want to develop. And so make sure you go back and review the notes before you try your homework. All right, guys, this is today's lesson on factoring trinomials when a is equal to 1. I hope you guys have a wonderful rest of your day.